Hi, my name is David Terr. Welcome back to Let's Make a Better World. And today's video is my first in a series of videos about how to really make America great again. My last video was what's wrong with America, basically. I talk about several ways in which we're declining as a nation. And we've been doing so, I think, for about the last 40 years or so. And this guy didn't help at all, in my opinion. Donald Trump, as you all know, he was president from 2017 to 2021. His campaign was Make America Great Again, but I think he made America a lot worse. And I think a lot of other people agree with me. So, how can we really make America great again? Well, there's a lot of ways we can do it. And like I said, this is a series. So, today I'm going to talk about energy production. And I'm going to start by talking about climate change. I think most of you know about climate change. It's been in the news for a long time, and it's real, and it is caused by man. That's been the consensus among scientists for over 20 years, and there have been a lot of spin doctors in the government trying to cloud the issue, but it is unanimous that we know that climate change is real. It's being caused by man. As a matter of fact, there's very good statistics on how much the Earth has warmed up. This map shows how much it's warmed up just in the last 60 years or so. And as you can see, especially around the poles, and this is the most critical part, the North Pole, it's warmed up between 2 and 4 degrees Celsius, and it's only going to take another degree or so before the Arctic ice melts. And once it does that, it's going to flood all the major coastal cities around the world, and it's going to be devastating. I mean, there's going to be a huge death toll, I think, probably in the hundreds of millions, mostly in poor areas like Asia and Africa, where people can't move so easily. So we know it's a problem, and it's caused by. And let me just show you some more. So here's some effects of climate change, and it's already happening. I mean, we don't have to wait until the polar ice melts. We're already seeing rising temperatures, as I showed you. We're seeing worse droughts. Some areas that used to be very fertile are suffering terrible droughts, and a lot of people are being affected by that. Not only that, but we're having terrible extinctions in various ecosystems, plant and animal extinctions, because we're affecting their environment by affecting the climate. We're having worse and worse forest fires. There's been terrible forest fires the last few years in California, which is where I used to live. And of course, we're getting worse storms all around the world. We're getting more and more hurricanes, and we had some terrible ones already. And we've already had some terrible floods. So I think you guys all know all this is going on. And it's due to climate change caused by man. So, and what's the culprit here? Well, it's pretty obvious. The culprit is fossil fuels, the greenhouse effect. That's why we're getting climate change. It used to be called global warming, but we actually don't know whether the effect is going to be a warming or a cooling. It's possible that some of the Arctic ice, when it gets in the Gulf Stream, might actually end up cooling the Earth, and we may even end up with another ice age. But we know we're affecting the climate. That's why it's being called climate change now. But let's just look at this graph. This is just 2 years ago, 2021. This is a breakdown of our power production in the United States back then. And I don't think it's that much different today. This is only 2 years ago. So in 2021, 90% of our power production was from fossil fuels, 32% natural gas, 36% petroleum, 11% coal. These are all contributing to climate change. I think they should be banned. I mean, in an ideal world, we'd ban fossil fuels because those are the culprit in climate change, and we'd switch to other forms of energy that aren't. And I think one of the most promising is renewable. That's this little green wedge in here. So right now we're getting 12% of our energy from renewable. That's not that much, but it's a lot more than we used to get. We are getting more and more energy from renewable. And here's the breakdown of renewables. I guess 20%, 7% wind. I kind of like the ones near the top better. I think some of these renewables actually will contribute to climate change. Biomass waste, biofuels, wood also, anything you burn. will create carbon dioxide, which is a greenhouse gas. So I don't like the ones on the bottom here. So, even among this 12%, I think about 2/5 of them are still going to contribute to climate change. So the good ones here are wind, hydroelectric, solar, and geothermal. And I think we need more of that. And they are doing a lot of this in some parts of the world. China. This is a solar plant in China, and look how big it is. And we have a few of these, but not that many. We have a big one near Primm, Nevada, which is near where I live. There's a big, huge solar power station right on the border. Um, but we're doing that much with it. We still have these disgusting oil refineries all over the country, and they're horrible. I mean, not just because of the CO2 and greenhouse gases they put off, but as we know, there's a limited supply, and the way we're getting it is pretty terrible. Fracking, and it's been a problem ever since the '70s. I mean, gas is outrageous because the supply is limited, and but we're probably going to keep using it as long as gas companies are making profit from it. Unfortunately, money talks, especially here in America. So. But what else can we do? I mean, yeah, the fossil fuels are bad, but what's good? I mean, I mentioned solar and also wind and geothermal. Those are all really nice, all the renewables. But what else? I think nuclear is a good option, actually. A lot of people really hate nuclear. It's not renewable. That is a disadvantage. And there are problems with nuclear. I'll acknowledge that. The radioactive waste is probably the biggest problem. But I learned something just a few weeks ago. It doesn't have to be such a big problem. What we're doing, the way we're getting power from nuclear right now, is very bad. And if you look at sort of the history of nuclear power, it started out people were very optimistic about it first. The first nuclear plants in the United States were built in the 1950s. In the 50s and 60s, people were very optimistic about it. They thought it would provide all our energy needs. And I think it was only in the 70s people started getting very skeptical about it. But a lot of it was ignorance. I mean, there were, most people don't know that much science. And I think in the 70s was kind of an anti science decade anyway. But what happened was a lot of people didn't know the difference between nuclear power and nuclear weapons. And one point I really want to make right away is that they're totally different. I mean, it is literally impossible to have a nuclear explosion like Hiroshima at a nuclear power plant because in order to do that, you have to put together a critical mass of uranium. Nobody is doing that in any nuclear power plant anywhere in the world. So that is not a problem. That is not a problem with nuclear power. There are other new problems. I mean, I already mentioned the waste, but I want to talk. I want to say something that hardly anybody knows. Um, we can reuse uranium rods. This was actually done in some plants in the '60s, but in the '70s they outlawed that. I don't know why. Probably just because of public discontent with nuclear power. Uh, but this is a really good idea. I mean, right now, every nuclear power plant in the United States is only using its uranium rods once. But we could be using them up to about 10 times. We can keep reusing it. And not only that will that give us a lot more energy, they estimate that the total energy we could get by reusing uranium would last about 150 years. But not only that, but it would clean up a lot of the waste too. Right now, if you just use the rods once, you're left with radioactive waste with a half life of about 100,000 years. That's very, very difficult to store and very dangerous. But if you use it 10 times, you're left with less waste and a shorter half life, and it's easier to store and easier to deal with. And I don't know why we're not doing that. We should be doing that. Nuclear is not a bad form of energy. There's other problems like nuclear meltdown, nuclear accidents. We've had two terrible ones already. Chernobyl. I'm sure you guys all know about that. Soviet Union, 1986. It killed hundreds of people and left an area about the size of Pennsylvania uninhabitable for, I think, 50 years or so. I think it's still uninhabitable. And there was another terrible one in Japan just a few years ago, caused by a tsunami. So I'm not denying that that's a problem. But one thing that a lot of people don't realize is that statistically, nuclear is much safer than fossil fuels. It's actually a very safe form of energy. If you look at the statistics of fatalities, oil plants, You have accidents, those things all the time. They don't make the news. I guess we're used to them. Coal plants are terrible too. Coal mining is a horrible job. There's mining disasters going on all the time. They've been going on for over 100 years, and I guess people are just kind of used to that. But anyway, so I don't think nuclear is bad. As a matter of fact, France gets 70% of its energy from nuclear. They don't seem to have a problem with it. We're only getting, I think, 8%. But what else can we do? That my favorite form of energy is nuclear fusion. This is the opposite of fission. We call fission nuclear power, but there's actually two kinds of nuclear power. There's fission and there's fusion. And fission, they're the kind of the opposites of each other. Fission, you take a heavy element like uranium, which is the heaviest naturally occurring element on Earth, element 92. You bombard it with neutrons and you split it, and the fragments are two smaller, lighter nuclei, and because of equals mc squared, the total mass is less for the fragments. And you get a lot of energy because you've converted the mass to energy. That's how nuclear power works. But fusion, fusion's the opposite. Fusion, you start with hydrogen, which is the lightest atom in the world. It's element one. And what happens? This is how the sun gets its energy. You start with hydrogen, and you smash two hydrogen atoms, two protons, their nuclei, together really hard. And if you give them enough energy, they'll fuse, they'll stick, and you get helium. And like just like with fission, the product it has a smaller total mass than what you started with, and that extra mass that disappears gets converted to energy. Actually, fusion produces about 10 times as much energy per mass as fission. So fusion's even better in terms of energy production. Not only that, but it's a lot cleaner. I mean, you're using hydrogen. Now think about it. Hydrogen is so abundant. I mean, water is H2O. I'm sure you guys all know that. So, and about 10% of the mass of water is hydrogen, and we got the whole ocean. I mean, we've got, like a virtually limitless supply of hydrogen here on Earth. And, the biggest problem with fusion is that it's hard to do. I mean, you have to heat up the plasma to like 100 million degrees, which is, and that's hard to do. You have to use a huge amount of energy to, heat up the plasma. And then, if you're able to get the protons to stick, then you get energy, and you have to get energy break even. You have to get more energy out than you put in, and nobody's been able to do that yet. Even though engineers have been working on fusion since the 1950s. I think this is crazy. I mean, think about it. We've been trying to build fusion plants like this. This is a tokamak, by the way. It's like a donut. This guy is inside what looks like a donut. If this thing were running, there'd be a very, very hot plasma inside here, and he'd obviously have to get out. But that's where the energy would come from, and you can find it in a magnetic field. This hasn't been very successful, but it's not the only design. There's also this thing. This is called inertial fusion. This is newer, but it's still pretty old. I actually visited a plant in Michigan that did this in the 1980s, 1984. I was an undergrad at the University of Michigan. Our physics department had a field trip to a plant, experimental plant in Michigan called KMS Fusion that was working on exactly this design. This is what's called inertial confinement. And the way this works, I think it's pretty cool. You have these lasers, these long things on the end are very, very powerful lasers. I don't know what the power, probably megawatts or maybe even gigawatts. But you got these huge, powerful lasers shining on a tiny little pellet, about a millimeter in diameter. You have a pellet of hydrogen. And a spherical pellet. You shine a bunch of lasers on it in all directions, kind of uniformly. And when you do that, if they're powerful enough, they cause the pellet to implode, and the pellet gets very, very small, and the hydrogen inside heats up. And if you do it, enough energy, you heat it up to 100 million degrees and get fusion. At least that's the idea. And I don't know if anybody's succeeded with this yet, but we're not putting a lot of money and manpower into this. I think we should make like a Manhattan Project to get energy from fusion, seeing how important it is. But anyway, those are the ideas I have for how we can create clean energy and ultimately save the world. And that's my video, and I hope you enjoyed it. See you next time.